Okay, that's probably way too much information for the person who just saw this problem. Yeah, with zero explanation.
I'm sorry, what are those little, what's that little M? Was that the top of the graph?
And, it's just, we don't know what's going on in between. The actual graph, if you look at it, does something like this. It actually doesn't have that little hill in the middle, or, little bump in the middle. I don't know. They were asking me if I should be able to sketch that without a graphing calculator. Yes, you should. At least know what the zeros are. I would probably try to make them a little bit nicer than the cube root of 2, okay? Yes.
If we just draw it as a little, we count it off.
Nope. No. Because you really kind of honestly don't know what's going on in between those. Yes. Is everything okay?
So what would you want us to write instead of if you were to?
Well, it depends. Do you have a calculator or not? Okay. If you have a calculator, then you should be able to graph that. Now, this would be a calculator question the way it's been stated because it says locate its extrema. There's no way I'm going to be able to do that without that calculator. Now, what feature on the graphing calculator am I going to use to find the top of that little hill? Right, you're going to find the min or the max with that. So you're going to calc max, which is above your trace button. So you're going to calculate that maximum point right there. That would be the only way to find that extrema. It's a relative max. We know that relative maxes are what kind of values? Y values or X values? They're Y values, right? Relative mins, relative maxes, absolute mins, absolute maxes, they're all Y values that occur at some X value. But you should be able to look at the leading term and determine the end behavior. What's happening on the right and the left. You should be able to write them as limits. Now, it absolutely disheartens me to death when I see something like this. See what I put there in the blue? I'll point to it. I want you to look at this. The limit as x approaches infinity from the, what does that plus mean? From the right. Okay, first of all, on a graph, where's positive infinity for x's? To the right. Okay? All right, now, what you're saying here is, I'm going to go to infinity. Then I'm going to jump over infinity, and I'm going to come backwards towards it on the right. What? How the heck do you do that? Doesn't infinity just keep going? So how do you jump over it, get on its right side to come this way? Same thing with somebody who says they're going to negative infinity and they're approaching it from the left. How do you do that? Okay, don't say that at parties, please. Okay? There's only one way to approach infinity and one way to approach negative infinity. You don't have any other choices. So I've seen that show up on tests, folks. You can't. The only time we use those pluses and minuses is when we were approaching a number like 7 or -3. We can talk about approaching right and left from -3. You can't talk about approaching infinity from any other direction than one direction. Yes, that's a one direction joke. So you need to be able to, the relative max on that, you can look it up. Why don't you just type it? You're going to have to use your calculator. I think it was like 1.19 or something like that. You'll have to use the graphing calculator for that because we're not going to be able to tell that without. You'll have to use the calculate max feature. Okay. 9 through 12, we need to match these up. Okay, so question 9. Leading term 7x cubed. What does the leading coefficient tell you about the right end behavior? It's going up, right, to positive infinity. What does the odd degree tell you about the left end behavior? It's going down, it's opposite. So we've got the right end behavior and the left end behavior. What's the y-intercept? What's the y-intercept on question 9? Okay, you got about 15 seconds to talk to your neighbors and figure out what the y-intercept is. Talk about how to find a y-intercept. Yeah. What do you plug in for every y-intercept in the universe? Talk to your neighbors. State Farm or otherwise. What do you plug in for x for every y-intercept in the universe? 0, right? So if I plug in a 0 for x, what do I get? 104, that's true. The constant at the end, as long as it's in standard form, well, I shouldn't say that. As long as it's not in factored form, we should be good. But just plug in an x value of 0. It'll make your life so much easier. I mean, when we start getting to, well, we can look at a factored one here and figure that out. Okay, so if it's 104, which one of those, and those are the left and right end behaviors, we definitely can rule out B and D. So you got choices A and C. What are you thinking? Yep.
I said C because
Okay, so if I'm looking at the pictures for A and C, what do each one of the vertical marks, what are those measurements equal to? Looks like 100, right? It says it goes from negative 200 to 400. So in this one, in letter A, we are lower than 100. Right here, we're right around 100, which would make a whole lot of sense with this. So I would have to agree that we're talking about choice C. Oh, I can't do it. So that one is choice C. How about 11? You've got a leading term of x to the 5th. Okay, find out what the right end behavior, the left end behavior is. Think about the y-intercept. Make a selection. Talk to the people around you. See if you agree with them. So the end behavior matches. But the problem is the y-intercept. You can see that that y-intercept is lower than 100 because it crosses below the first mark. And each mark is 100. So this one crosses right close to 100, so that makes more sense why it would be the right one. So we've got a positive 1 leading coefficient. What is the right end behavior? What is the right end behavior? Because we got a positive 1 right there. Positive infinity. Okay, what's the left end behavior? Because we have an odd degree. It's the opposite. Y-intercept? 70 minus 1. You can't feed into that junior high humor, seriously. Okay. Which choice are we talking about? It is choice A. If you look at it, you have the same end behavior and you're crossing the y-axis below the 100 mark. So that's why it has to be choice A. No, don't ask. Okay, question 17. Graph the function. Okay, do you know what the zeros are? Yeah, what do you got? We got a 1, sure. And a -2, good, good. And a -3, yeah. Set the factors equal to 0. Nice. Now, I noticed that each one of these exponents on these factors is a 1, okay? The term that you are looking for is multiplicity. Do you remember that one? Okay. We talked about how, last year we talked about how odd multiplicities tell you something and even multiplicities tell you something. Odd multiplicities do what? They cut through the axis. Now, I'm not going to get picky about how they cut through the axis. Like a cube cuts through the axis a little bit different than a first power does. But I'm not going to sit here and argue with you about, you didn't, have the little curve in it like a cubic does. No, I'm not going to worry about that. If you can cut through the axis, you've got the idea. Okay, the even one, there was a song about the even multiplicities. Okay, right, I Kissed the X-Axis and I Liked It by Katy Perry. So you have to look at the words if you don't know the song. Okay, go back, study it, learn it. None of these bounce like that. None of these ricochet off the axis because all of them have an odd multiplicity. It's the exponent I'm talking about, not the actual 0. So don't look at it and say, well, if the 0 is an even number. No, that's not what I'm talking about. I'm talking about the exponent. Do you know how to come up with the leading term? We'll call it the LT, not Lawrence Taylor. What? Okay, should we go through and FOIL x minus 1, x plus 2, and x plus 3 to find the leading term? We could. There is another option. The only thing I need are the firsts. Make my life easier and just multiply the firsts together and you'll know what the leading term is. So what do we got? X cubed. All right, so what's the right end behavior? It's positive leading coefficient, right? So we're going up to positive infinity on the right. We've got an odd degree, so the left is opposite.
You said you have odd right of even, so is it odd?
The odd multiplicities which you see right here, they're all 1s. Those are the ones that cut through the axis. Okay, the even ones bounce, but we don't have any bouncers. I really want to get 2 black t-shirts that say even multiplicity. Okay, and go to a bar and make the bouncers wear them and take a photograph in front of the bar. Even multiplicity because they're the bouncers. Come on, folks. Seriously. I gotta do it. I really have to. Okay. That could be my first meme. Yeah. Okay. I've never created a meme, so. All right, now.
Could you draw it just so we know?
Oh yeah, I'm definitely going to draw this. So if the right end behavior goes to infinity, go to the farthest 0 on the right and attach the end behavior. Go to the far one on the left and attach the end behavior there. Now, if you know that each one of them cuts through the axis, and folks, I have no idea how high or how low it goes. Remember, I'm not using a graphing calculator at the moment. I'm guessing. I'm sketching this thing. If I need to find the extrema, I need to use a graphing calculator. All right? If I'm just asking for the zeros, then we should know that we're dealing with 1, -2, and -3 because we got those from the factors. Okay, but you're only going to get extrema if you actually type that in. And no, you don't need to FOIL it to type it in. You can type it in exactly like those factors are written. Don't waste your time. If you're doing this on a test, I don't want to see you foiling this whole thing out. For what? It doesn't give you great information to do that. Okay, jump down to question 21.
Wait, what's the extra?
You have to figure that out with a graphing calculator. Solutions are all online. Now, do you not remember how to use the graphing calculator for that?
No.
So you go to set your calc, and it'll be in there. So if you want the minimum or the maximum, you'll find it in there. Okay? You can. Question 21. So what are the zeros on question 21? We got a 2, a -1, and a 3. Now, what are the multiplicities of those? 2, and a 1, and a 1, right? I'm looking at the exponents, folks. You should probably find the leading term. You should probably sketch the graph. Okay? Do that right now. Find the leading term and sketch the graph. And then we'll talk. Leading term. What's the leading term? It is x to the 4th. Now, why is it to the 4th? Well, folks, remember when we multiply those firsts together, this one is x squared times x times x. And that's how we get our x to the 4th. So what's our right end behavior doing? It's definitely going up to positive infinity. Since we have an even degree, the left is the same as the right.
I'm sorry, what's the LT?
Leading term. Unless you're a New York Giant, then it's Lawrence Taylor. But, you know.
Since it goes infinity on the you guys made it positive infinity on both sides, does the limit not exist?
Well, the end behaviors do not exist. That's true. But we just want to know, is it going up or is it going down? Okay, we know that the limit to positive infinity and negative infinity does not exist. Folks, polynomials don't have horizontal asymptotes. There isn't a polynomial out there that fits that criteria, unless you do some weird things to it. Okay, but if it's just a straight up polynomial, these things are going up on both. Are these things bounded by any chance? I mean, remember the definition of bounded means they have to be bounded above and below. Are these things bounded above and below? No. Some of them are not bounded at all, and some of them are bounded above, and some of them are bounded below, but ain't none of them bounded both ways. Okay? Not a polynomial anyway. Yep.
What's the correlation between the zeros and the
The multiplicities tell me something about the graph. All right, we got an even and two odds. Both of these are odd.
And they'll tell you what cut through or around.
Yes, I just need to know.
Okay? Yes, multiplicity. Sorry, I abbreviated. So 2, -1, and 3. Attach your end behavior to the outermost zeros. What's happening at 3? Is it cutting through or bouncing? We got an odd multiplicity, that means it's cutting through. What's happening at negative or at 2? It's ricocheting off the axis, and then over at -1, it is cutting through. So the ricochet occurs at 2. Now, what it's doing in between those things, we're just sketching it. We know that it comes back down and goes back up. If I needed to know the extrema, I'm going to have to use a graphing calculator. There's only one extrema on this graph I should know without a calculator. There's a relative max that occurs at what? What is the relative max here? The relative max is 0, and I'm so proud of you for giving me the y value. It occurs at x equals 2. That's the only one you should be able to tell without a calculator. Other than that, you're going to have to reach over, grab the calculator, graph the doggone thing, and then check for those relative mins. Okay, and questions like this that ask you to describe end behavior with limits, yes, you will have to write your limits with the correct notation. But you've got the answers to the limits right there and right there. So make sure you can do that, because you'll lose credit if you're not going to write your limits correctly. Okay. Those are more of the same. Match each graph or function with its graph. Okay. 29, we have 20x to the third for the leading term and a y-intercept of 55. So what's my right end behavior? Going to positive infinity. We've got an odd degree, so what does that mean about my left? It is opposite. Okay? So that gets rid of those two choices right there. Which one has a positive y-intercept of 55? That is choice A. So 29 goes with this one. (31). We've got 44x to the fourth and a y-intercept of 3. Now, what's the right end behavior if the leading coefficient is positive 44? It's going up. The even degree tells me the left is the same as the right. So now we definitely know that one of these two down here, C or D, is the answer. And which one has a y-intercept of 3? It has to be C. So 31 goes with that one right there. Okay, finish up those homework questions and we will be on to 2-4 tomorrow.